number 43 of the Piezo Shock Show. We had a couple of days off, but we're getting right back on track. So today I'm going to answer the question. This is a very deep question, so I am just going to take it how it went according to my notes, but how to talk to piezo ceramic suppliers. So when you're obviously building an ultrasonic device, well, you're going to need your piezo ceramics because the microstructure and the piezoelectric phenomenon is a unit cell or microscopic phenomenon. Therefore, you can actually, and the ability to apply electric field, you can apply it at a very fast frequency, high frequency. Therefore, you can actually cause motion at that, ultrasonic frequencies, therefore stimulating ultrasonic resonance. So now that you're convinced that you need a piezo ceramic to implement in your ultrasonic transducer project, which you already knew, let's just talk about a little bit more on some things related to talking to ceramic suppliers. Now, in the last episode number 42, we had a pretty long interview with Jack Gray, who is a liaison to Asian piezo, certain factories who produce piezo ceramics and also finished transducers. So my curiosity there, and I guess I was kind of picking at, well, where does his business fray? I always speak in a positive light, anyone who comes in the interview, but I just sometimes want to know, like, when should we go with Asia and when should we go with Europe or America? From what he was saying, there are not a lot of potential benefits for going to America or to Europe for your ceramics. When we talk about tolerances, when you talk about quality, both of those are, as long as you know the right suppliers and you talk to the right person who knows them, Jack, and you can look at his some contact information for him from the last video, episode number 42. So when should you choose and when does it become very clear that you need you need an American or a European supplier versus one in Asia, mostly in China. So the couple of thoughts that I had on when you might want to choose one or the other. So the nice thing about, I would say, Asia is, a lot of those factories are producing a huge quantity of ceramics, and particularly for getting a finished product, they are very efficient at building huge numbers of finished products. So you get a good amount of confidence going in that if you do have a standard part that you're ordering, or a standard size for them at least, then you will be, riding the bandwagon for that, the quality of that product, because those other products that they're building are also going into other products, into the hundreds of thousands number. So that's a good benefit I see there, is that they're factories of scale for sure. And not to say that doesn't happen in Europe and America, but I think Asia does have a bias, to doing that due to the labor prices and the fact that larger companies with really huge orders, they do go to Asia for that type of manufacturing. The other difference I see from Asia versus America is when there are issues and problems with the ceramics, which happens. These are multi-step development, and they're the processing of piezo ceramics, it takes several steps. There are known events. It happens. Every company has seen such events where properties will shift, or you might see quality issues from time to time. That's understandable, but I think the direct communication between your company and the supplier, it is going to be less if you're going to be talking, let's say, through a liaison, but due to the experience that Jack was saying, that he has a very long history, definitely believe that that's not going to be a problem. But one can imagine that, well, we'd be able to talk to the engineers and it's not a really good idea to get your suppliers involved with your own device troubleshooting, because there's so many different things going on in your device. If you're trying to troubleshoot your device with your supplier, that's the wrong avenue. You want to talk to somebody like me, or perhaps if you're going to Asia, somebody like Jack can also lend in some of that expertise. as part of the sale of the piezos. But if you want somebody very specific, honing in on that, supporting your device to really understand what is going wrong with the ceramic so you can tell the suppliers the correct information about what's happening and what you've tested, then you probably want to go with someone like me to fill in that gap. But you will more easily be able to contact, let's say, the engineers on their team. However, that's not necessarily true, because for larger companies, those specific engineers will be less available for you, and it's actually very time intensive and costly for them to troubleshoot a device or a problem with you, unless there's a glaring issue that's their fault, like a huge quality issue, like you take the ceramic out of the box and the electrode is half done, or there's chips and there's things like that. But also, if you want a more custom material, my gut would tell me that if you want the custom material properties to match specific permittivity or other properties that are not just straight datasheet materials, I would tend to want to go with a European supplier. That's just my gut feeling. I'm sure Jack would say otherwise because of his deep experience, but I don't have that same deep experience. So just my perception is that you have better communication, and perhaps they're more research oriented in terms of developing new materials, like lead-free materials. They do have a bit more expertise, but Jack did mention those Asian suppliers, if you choose the right one, they do know how to tailor their materials for different properties, and they also know how to get their system back in tolerance. Let's say there's some change and that causes a permittivity change. Well, they'll know how to get that back to what it should be according to the data sheet and an acceptable value. So I think there's not a whole lot of reasons to go with a European or American company versus an Asian one. It is more of a comfort. But I think that through the liaison working with an Asian supplier, there's still there is a lot of you get a lot more confidence that you kind of have somebody on your side there. So yeah, I found that discussion to be really awesome and interesting, and watch it. It's episode number 42. So let's talk about the general process about how you go through a supplier. So you decide on a supplier, they're reputable, you found them in a certain way. There are many American and European ones, though who they are is not a mystery. So firstly, does it work? So you design your device, and you may even want to start with a few vendors, samples from a few vendors, just to see which ceramic works better. Now, even though their material properties may be similar on the data sheet, what you receive may vary in terms of how they perform in reliability, or with other aspects of their construction, and simply how in what condition they arrive to your facility. So basically, get different, get similar materials. Obviously, if you're building a power transducer, you'll need PZT4 or 8. Go 2 episodes back and I explain what that means. PZT4 and PZT8, they're for higher power, or PZT5 for sensors and low frequency actuators. Basically, so try before you buy, prototyping with different. Once you have a decent, reasonable prototype, just trying with different ceramics to see if you see any appreciable differences. And then obviously, if you do, then ask why those differences are there, and learn to try to understand and characterize why they might occur. They may not be even due to the piezo ceramic properties themselves, but they could be due to tolerances and other kind of aspects which could be overlooked. So seek out different suppliers. Try before you buy for a specific prototype. Or try before you buy, or it's not super critical that you do that, because many times I've definitely seen products just develop with one ceramic. But if that naturally and easily comes into your work stream to have an opportunity to try different ceramics, then it's not. I think it can only lead to beneficial results. Especially when your cost concerned too, and maybe if you don't, because a lot of times the reason you might choose a supplier over another supplier is just customer support. Like you feel like you have good support from their company, that they are doing, their support, their customer support, even on the business side, how easy they are to deal with on the business side is actually quite important as well. In order to get shipments, in order to get data, how compliant are they to and dedicated do they seem to helping you out with information, and not necessarily always telling you what to do. Now you do want now a lot of times when folks talk to ceramic suppliers, they're not ultrasonic transducer experts or really very talented engineers are able to create new and unique devices that work. But when you start talking to a supplier, there are questions which are asked which become difficult to answer. And you sometimes walk away feeling kind of not confident. Like you feel like the supplier knows what they're talking about, which is true, but you're not sure how to answer them in a way which supports your technical and business objectives. So that's where someone like me might come in as a third-party ultrasonic transducer expert, helping you, sort of supporting your needs to a piezo supplier. So there becomes a win-win situation. So after you choose a ceramic, now you're going to want to specify what specs are going to be on your ceramic drawing. So here's a really simple approach, which is often used, that you just take their ceramics and you make a statistical tolerance. So that's typically done on resonant frequency, impedance, capacitance, and the coupling factor, or you can do the difference between the resonance and anti-resonance frequency, which makes things a little bit easier to calculate. Additionally, then what happens is that the technical specifications of the entire device are actually just based on how you characterize your device as built, with your as-built transducer and as-built circuit. So they're more about observations, like this is what a normal transducer does, hence this is what a normal circuit does with a normal transducer, and that's going to be our normal performance. So you create specifications around that. So that's very specific around your system maintaining balance and maintaining approximately the same level. But when you do, let's say, have natural types of variation, your ability to counteract that and adjust in the system is going to be limited due to those observation-based tolerances. So another approach, and you can perform a hybrid or however you'd like to, you see it's best fit for your application. But you can also so option B I had, so you create red flag tolerances. Like that when the quality factor is, when it should be 1,000 and it's 200, there's no way you're going to install that in your ultrasonic transducer. You're not going to waste your time with that device, or if the frequency is way too low, so what's way too off. But then the next part is, like, what is the functional tolerance? If the capacitance of your transducer is too high or low, let's say the driving circuit is going to produce a different voltage, which produces a different power. Let's say it's not closed loop, it's open loop, and you are actually depending on your ceramics, on your transducer's property to help regulate that power delivered due to the nature of the circuit. So you can actually create functional tolerances based on the ceramic, which actually require different tests to do to determine those tolerances on how your device will react and behave in those areas. So you're actually able to expand your area of permissibility even beyond your statistical tolerances, because you may put your statistical tolerances at a certain number today, but over time there may be a shift in device performance, and usually in every transducer project there is a point in time where the transducer properties shift, the ceramic properties shift, and that causes a huge root cause analysis effort. I've seen it at every company, from expert to new, that this will happen eventually. So be aware of it. The only time where this might not happen is when your loaded transducer has a impedance, let's say 4 times as much as a bare transducer. That means that most of the loading is occurring due to the external environment, so you can kind of be sure that whatever power you're putting into your transducer, it's getting into your environment. But in many cases that doesn't happen. There's a significant amount of influence on impedance from your transducer itself. Therefore, you're going to be needing those functional tolerances. Other things you're going to need to include in your system is calibration due to those variances. And also, very importantly, analytical test specifications. So coming up with, so whenever a root cause analysis effort happens, there's at the end of it, what I've seen is always a new test method to test that problem. Be it, let's say it's a mechanical defect, or if it's an actual functional defect, which occurs from time to time due to assembly variation. So having those analytical tests with actually implementing them ahead of time and working on them continuously to understand more and more about your device, more and more about what makes it actually work properly is super important. So here's just a kind of a general scope of what a ceramic drawing could look like. Let's say this is a ring. You'll have three, isometric. You'll have two other 2D drawings. You'll have tolerances, plus or minus, however much. You'll have flatness, and usually your ceramic supplier will give you these dimensional tolerances and the other tolerances which are there, so you can actually, they usually are pretty good for the most part. So you can always, however, check them on your side to make sure that the concentricities, to make sure that the flatness, the pitting, the low and high spots, the perpendicularity, all of these are really important, especially for bolt Landevin transducers. So kind of verifying all of that once you get it, but also what's also usually on the spec is what's the resonant frequency plus or minus something, either statistical or it's functional, and there's the capacitance, there's the coupling factor, or you can just provide the difference between the resonance and anti-resonance frequency, which tends to be an easier number to calculate and less prone to like which equation did you use for that. The final tolerance I have here is impedance. An impedance and a coupling factor together do inform me about what the quality factor is, so there's not really a need to measure quality factor, especially because it changes so much at higher power, but that's something that could also be included, and you can provide some script inside of your impedance analyzer to provide that measurement. So that was all for this episode of the Piezo Shock Show. We spoke about Asian versus European and American suppliers. We spoke about kind of how you develop your tolerances, either if it's statistically based on purely observation, or it's based off functional test and analytical test to see what you actually what your system can really handle, as well as importantly putting in calibration steps in case there is a shift. It doesn't require you to, there's a shift in performance, but not representing poor quality. So there can be shifts in performance, but the quality of your ceramic, its ability to maintain integrity and under electric field and stress, if that's maintained, you can still work with that device and it can function as long as you are as long as you're aware of how to adjust your final system accordingly. So you've been watching the Piezo Shock Show episode number 43. This is your host, Dr. Shirkani. I look forward to seeing you in the next video coming soon. And look in the description for links on the presentation notes today, links to sign up for updates in your email. You'll also get those presentation notes there, and also a link to my consulting services and offerings in case your company needs help in the development and analysis and troubleshooting of your transducer product. Thank you, and I'll see you next time.